Okay guys, today we're going to be covering the mole concept, and normally we do a lab activity that you weigh out some chemicals and calculate the moles and that sort of thing, and it's great to do with hands-on, but we're having to do it distance learning, so I'll give it my best shot making this video. So for what you'll need is a periodic table, and there's one on Blackboard that you can print out, or there's one, I also gave a link for this one, the dynamic periodic table, which is really helpful, can be helpful in chemistry class. So when you hover your cursor over a certain element, it will show it in the big box here, and I've shown with the arrow. So we're first looking at copper. So you'll need a periodic table, and you'll also need a calculator, got here, and also a scale or a balance. So we've got these three balances weighing out three different things. So let's look at those. So first we've got this copper beads, copper shot, and here's some information about that. So copper, 1 mole is 63.5 grams, and we find that out by looking at the atomic weight of copper in the box here. You can see 63.546 grams, so we can just round it, but that's the atomic weight, gram atomic weight of copper. And so we weigh out that amount, 1 mole of copper, and it looks like this. So here's our, roughly, this is the closest I could get at 63.44 grams, but close enough. So that's what a mole of copper looks like. So then a mole of sodium chloride, so salt, table salt, the information here for sodium chloride, so it's a compound, so you have to add up each of the elements, what their atomic weights are, their gram atomic weights. So you look on the periodic table, and there's sodium at this far left end, so you can see it's roughly 23. We'll round it to 23, and then chlorine over here on the far right, it's about 35, we'll say. So you have to add those up to get the formula weight, and that's 58 grams. And whenever you weigh out chemicals, you can just look on the bottle, the side of the bottle, and you can see here, on the top line there, 58.44 grams is the formula weight for sodium chloride. And this is what 1 mole of sodium chloride looks like. You can see the white powder in there. It looks like it's more taking up more volume than what was the copper taking up. And then the next one here is a mole of water. So water, the information here, you have to add 2 hydrogens, 1 oxygen. You add them up according to the periodic table, and you have 2 hydrogens, 1 oxygen. You add them up, and it's 18 grams is 1 mole. So I got as close as I could to 18 grams. Maybe we could add a little more. Okay, so close enough to 18 grams. And this is what 1 mole of water looks like, the 18 grams. I might take it from different angles so you can see how much is there. So first thing, just think about what's the same about all of these. What's the same? You can even pause the video and think about that. So what's the same is they're all 1 mole, and that means, so 1 mole, 6 times 10 to the 23rd is Avogadro's number, and that means there's, for example, 6 times 10 to the 23rd atoms of copper here. And here there's 6 times 10 to the 23rd formula units of sodium chloride. So if you think of the sodium and chloride together as one group, one formula unit, there's 6 times 10 to the 23rd of those formula units in the dish there. And then with the water, also 6 times 10 to the 23rd molecules of water, or formula units of water. So that's what's similar about all of these. They're 1 mole, and they have that number, the same number of formula units. And then what's different about all of these? You can even pause the video and think about that. So they're different in the number of grams, of course. So copper, it was 63.5 grams. Sodium chloride, it was 58 grams, and water is 18 grams. Okay. So then the next concept, just wanted to, let's figure out, let's put some more copper on there. So we'll just pour some more on there and pour some more sodium chloride on there and some more water. So now we're going to have different gram amounts. This one has, the copper now has 234.53 grams. The sodium chloride has 178.84 grams. And the water has 33.72 grams. So let's do this. Pause the video and calculate how many moles are in these pans now, each of these weighing dishes. How many moles of copper are there now? And you have all the information you need now. How many moles of sodium chloride are there? And then how many moles of water are in this dish? Okay, so hopefully you can pause the video and calculate those. And then the last question is, what did we need to figure out how many moles are in each of those? Did we use a special mole measuring machine in the lab? So all we really needed was a periodic table to get the formula weights, a calculator, and balance. So hopefully this makes the mole concept a little more understandable.